Hello students. So in this video, we would look into the next set of concepts in set theory. In our first two sessions, we have learned the basic introduction and concepts of sets. Then we understood how to express a set using the set builder method and the listing method, right? We also understood how to denote whether an element belong to or does not belong to a set, and we understood what is the meaning of order of or cardinality of any particular set, right? So we have covered these things in our first two videos, and we have seen the practice problems related to these also. And in our today's video, we would be concentrating on these following points. We would understand what do we mean by something called as a subset, a superset, okay? We would understand what is meant by a universal set, what is a complement of a set, and finally we would move on to power set. Okay, so we will cover these five concepts in our today's video. We would see some of the quick practice problems, and that would be the scope of today's video. So let's get started. Okay, let's get started, and we will start this session with a concept called Venn diagram. Venn diagram. Okay, so VENN Venn diagram. And students, remember, Venn diagram is a very important and strong graphical tool to understand and analyze a lot of problems related to set theory. Okay, and this is a graphical notification. So this is nothing but a graphical notification or illustration or expression of a set. So we knew that earlier we knew two methods of expressing a set. One was set builder, right? One was listing. And now one more graphical method we are saying that is nothing but Venn diagram. Okay. And the basic concepts of that is, so say if I'm saying there is any set A equals to 1, 2, 3. Suppose these are the three elements that I know in the set. So obviously I have defined the set using listing method. Okay. If I want to express this set in terms of Venn diagram, the way I will do is I will first draw a rectangle. Okay. And this rectangle indicates the boundary of the discussion in in graphics, right? So, and this is called as U, the universal set. Universal set, we'll understand what is it in a little more detail in few minutes, right? And any set A is indicated by a circle or an oval shape in this boundary. Okay, obviously when we are drawing with free hands we may not draw a perfect circle, but that's fine. Okay, so any closed area within this universal set can be indicated as a set A, and normally we indicate the elements of this set within this, right? So we distribute it like this. Okay, now if I will define one more set, suppose set B equals to suppose 4 and 5. Okay, so in this universal set, probably I can write something as B, and then I can write 4 and 5 inside it. Okay, so this is how we normally denote sets in Venn diagram. Any set can be denoted using a oval shape or a closed surface within a rectangle. This rectangular set is called universal set. Okay, and these are your individual sets. This is how sets can be denoted using the Venn diagram. Okay, there are a lot of analysis that can be done using Venn diagram. And as and when I introduce each and every concept of the set, subset, superset, and all, I would keep drawing the corresponding Venn diagrams, right? So that we'll get more hands-on with it as we move along the set theory. Okay, so let's begin our journey with the first introduction, or that is related to subset. Okay, okay. So say I have a set A, I have a set B. So if I'm saying A is a subset of B, so let us first see what is the notation to indicate that A is a subset of B. Normally we do A, this kind of a sign, and B. This means A is a subset of B. Okay? And if I want to indicate B is a subset of A, I would indicate B like this and A. Okay, sometimes you would see a notation like this. This is also fine, this is also correct. Okay, so this actually means subset or equal to. Just like you have less than, equal to, and less than sign, you have subset and subset equal to. And the reason why I have indicated the analogy of less than, equal to, and less than is because when we are comparing two numbers, right? Suppose I'm saying 2 and 5, I can say that 2 is less than 5 or 5 is greater than 2. Both are equally correct. And if I'm saying 5 and 5, I'll say 5 is equal to 5, right? So like when we compare two numbers, we use the logical operator as less than, greater than, or equal to. When we compare two sets, we can indicate that whether set A is a subset of B, or there's another term which I'll introduce in few minutes, or B is a subset of A. If they are equal, we can also write equal to. Okay, now let us understand in Venn diagram what does this subset mean. Okay, so so subset is nothing but, right? So if I'm saying A is a subset of B, that means suppose this is my universal set. Okay, if this is set A, so set B should be something like this. Okay, such, so if they are like this, then obviously any element that is inside set A, it is also in B, right? But when something is in B, it is not necessary that that would be in A. Okay, I repeat, A subset of B, in the graphical representation or in the Venn diagram, we can indicate it like this, that this is my universal set. If this is set A, set B would completely, subscribing it. So obviously that means anything that is part of set A will also be part of set B, but the reverse side of this is not true. So anything that is part of B need not be part of A. Okay, so that is why we write it in your set builder method as A subset of B when X such X belongs to A implies that X belongs to B. So any element that is part of A automatically implies that it is part of B. In that scenario, we say that A is a subset of B. Okay, so that is how a subset is defined. And sometimes people call it as a proper subset because it is not equal to, so A is little smaller than B. And if we want to understand it more clearly in our day-to-day life, so I can say that my vision system is a subset of my entire body, because obviously vision system would mean my eye, my retina, my pupil, and all the mechanism, the nervous system that it connects it to my brain, so that I'm able to see things, right? So this is part of my entire body. So my vision system is a subset of my human body, or I can say my digestive system is a subset of my body. So anything that is part of my digestive system is automatically part of my body. So in that sense, we understand subsets in the theory of the set world. Okay. So with this, let us move on to the next one, that is called superset. And superset is just the opposite of it, right? So superset is just the opposite of it. If so, here your B is the superset of A. B is the superset of A. If B is a superset of A, so X such X belongs to A indicates that X belongs to B. So that obviously means B is a superset of A. So B is larger. B already has A inside it. So like we say, 2 is less than equal to 5 and 5 is greater than 2. Similarly, we are saying here that A is a subset of B and B is a superset of A. So the term that we use here is superset. Okay. So normally a superset would have more number of elements, and your subset would have lesser number of elements. So if I ask you that there are two sets, A and B, so order of A and order of B, what should be the relationship? So obviously order of A would be less than or equal to B. When A is a subset of B, when it will be equal, when they are subset or equal to. When it is equal to, the number of elements will be same. Otherwise, B will have at least one element more than the subset of it. Right? Now, one quick question. So, so can you tell me? Can you tell me if I say phi set is a subset of n set? Is it true or false? So to answer this, let us go by the definition of subset. Okay, sorry, I wanted to say subset, right? Not equal to. Phi set is a subset of n set. Is it true or false? Let's see. Okay, so the definition says A subset of B when X such X belongs to A, X belongs to B. So phi will be a subset of n set if anything that is part of phi set is also part of n set. Now, what is the element of phi set? Nothing. If nothing is an element of phi set, so that nothing is also an element of n set. So remember, it has an identity that phi set is a subset of any set that you may define in the world. Okay, so phi set is a subset of any set that you may define in the world. Okay, so you may note it down, and then we will erase the screen and we'll move on to the next concept. Okay, now let us move on. So we have understood subset and superset both in Venn diagram and in set builder methods, right? So let us move a little more and understand something called as your universal set. What does it mean? So we have denoted that in a Venn diagram, this rectangular set which we are indicating as U, this is called as your universal set. What does it mean? Normally, whenever we get into this logic and set theory, we normally discuss about a certain scenario, and there is a possibility that these kind of things would be a part of my discussion. So for example, if I go to a doctor and I want to talk to him or her about my health problem, so anything related to my body would be the part of the discussion, right? So it could be my my eye system or my vision system. It could be my digestive system. It could be my respiratory system. So all these systems taken together would be the universal set, or the largest possible set under discussion. For example, let us take another example. Say I want to discuss about the number of or the elements or the numbers between 1 to 10. I want to discuss about the ones that are prime, the ones that are not prime, the ones that are even, the ones that are odd. Okay, so I have defined four sets. Okay, so set 1 is prime, so which means, and I have defined x such x is a prime number, prime number, and x is less than or equal to 10. Okay, similarly I have defined even numbers. Okay, e is a set of x such x is an even number and x is less than equal to 10. Similarly, o is a set of odd number, odd number, and x is less than or equal to 10. Okay, even, odd, prime, and say composite. X such x is a composite number, composite number, and x is less than equal to 10. So if you see, when I'm discussing about these four sets, P, E, O, and C, my discussion revolves around numbers 1 to 10. Okay, so which means suppose if I write here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I write them like this, right, then this is my universal set. All the numbers or all the elements under discussion taken together is called as the universal set. Then let me define my numbers. First one is P. X such X is a prime number. So what are my prime numbers? I know that one, no, okay, I'll leave one. Okay, so 3, 5, 7, and 9. So let me do one thing. Let me bring 7 here. I'll bring 6 here. I will put 2 here. That's fine. Okay. So my prime numbers would be all these 2, 5, 7, and 3. So I can say this is my set P, and the elements of set P are taken together. Though it is not an oval shape, still we can denote like this in your Venn diagram. That's okay. Okay. E, even sets. Even sets should be 2, 4, 6, 8, 10. So this would be my E set, right? This is my E set. Okay. Then odd set. Odd set would be, let me bring this 3 also here. Okay. So that it will be little easy to draw. Okay. So I'll make this as my even number set. So this was my odd number set, right? So if I want to calculate or if I want to take together all the odd numbers, then it would be my 3, 5, 7, 9. This is my odd number set. Then if I want to take the composite numbers, it would be 9, 4, 6, 8, 10. So this would be my set of composite numbers. So here the diagram has gone a little complex. So don't worry. What we can do is we can redraw them separately. Your suppose prime sets. Then we can say your, okay. Let us now redraw them here. Okay. We'll have four things. Prime. So let us put all the prime numbers together. That is your 2, 3, 5, 7, and 9. Okay, 2, 3, 5, 7, 9. Let us put all of them together. And then all the composite numbers. So 4, 6, 8, 10. Right? And say, let me put 2 also somewhere here. Okay, 1 2 3 4. So only 1 2 3 4 5 6 7 8. Only one is left out. Only one is left out. 2 3 4 5 6 7 8 9 10. So all the numbers are here, right? So this is my prime set. Then my odd set, 3 5 7 9. This is how I can denote my odd number set. This is how I can denote my even number set. Okay, and then my composite set can be defined as only your 4 6 8 and 10, only this. So this will be my composite set, and the entire thing would be my universal set. So here if you see, any element that is a composite within 1 to 10 is also an even number. So I can say composite set is a subset, or your composite set is a subset of your even number set within this boundary, not for all the cases. Okay, similarly about other sets I cannot say anything with certainty, because some elements are common, some are not common. And if you see here, that is one element that is not part of any of this set, that's okay. Okay, that could be few elements which are not part of any defined set that we are discussing under our discussion. Okay, so this is how we indicate your subset, superset, and universal sets in our set theory. Okay, so take a note of it, and then we'll go to the next concept. Okay, so couple of other things that we should know about subsets. Let us go into that. Okay, that is related to your power set. Okay, so say we have any set A defined as 1 2 and 3. Okay, then power set of A, is x such x is any subset of A. Okay, so if I take all the subsets of A as elements of a set, then the set that I'm getting, that is called as a power set of A. What does it mean? So in this case, what are the elements of A? 1, 2, and 3. So can I say that if I suppose define a set as this, so say set P equals to 1, set Q equals to only 2, and set R is only 3. So can I say that P is a subset of A? Yes, because what is the content of A, or what is the element of A? 1. So 1 is also contained in A, right? So any element that is part of set A, if it is part of set B also, then I can say this one is a subset of this. So I can say P is a subset of A. Here if you see element 2, that is part of set Q, also part of set A. So obviously Q is a subset of A. Here your set R, which is only your elementary, R is also a set of A. Similarly, if I take two elements together, okay, so say I define set S. If I define set S as 1 2, set T as 2 3, set U as 3 1. So obviously set S is also a subset of A, because the elements that are part of S are also part of A. Part of T are also part of A. Part of U, 3 and 1, that are also part of A, right? So these three sets are also part of A. Okay. Now someone says that I'll define a set V that is 2 1. So you can say that S set equals to B set because their elements are same, cardinality is same, everything is same, right? So S set is equals to B set. So that is why even if you interchange the positions of a set is not changed. So you don't need set V in this situation. So I can erase set V and I can define one more thing as set V, like the entire thing, 1, 2, 3. 1, 2, 3. So this entire thing is also a subset of A set. Okay. So these are the all possible 7 subsets of set A. Now, a few minutes back, we studied an identity that phi is a subset of any set in the world. Okay. So if we write all these sets together, that is 3 plus 4, 7 plus 1, 8, then we will get power set of A. And how we should write? We know that now I have got all the elements. If I know all the elements, I can use the set listing method to indicate or describe that set. So I'll write power set of A is nothing but this is element one. Notice here the usage of curly braces is very important. First, put one set of curly braces for the set. So that is done. I have done that. Then take all the elements. So first element is 1. If you leave this 1, if you just write it like this, then it's wrong because 1 is not a subset of A set. And in power set, all the elements should be subset of the parent set. So you must put this curly braces the way it is. So sometimes in exam they will try to confuse you with by using multiple curly braces. So be a little careful about that. So one will be a subset of it, then the second subset will be 2. And if you see, every subset of this set is being written as one element. Okay. Okay. So every set when written as subset, sorry, every subset when written as an element, that becomes the power set of a set. So the next element would be 3. The next one would be you take 2 at a time, 1, 2, 2, 3, sorry, and then 3, 1, right? And the last two would be 5 set and the whole set, 1, 2, 3. Okay. And the biggest or your bigger curly braces I have already given from the beginning. So that is where it is right. Okay. So if you miss out any curly braces, you may not get the right grade in the exam. So be a little, careful about it. Okay. So the way you should do it, whenever you are asked to find out the power set of any set, okay, whenever you are asked to find out power set of any set, so always do it like this, that power set of any set A is first set write as phi, last set write as your universal set or the complete set, right? So that will be your universal set. Okay. Rest take first take one element at a time. Then you take your set of 2 elements. Then you take set of 3 elements, set of 4 elements, set of 5 elements. How many number of elements are there possible in the set? You need to take those many combinations. Okay. And there is one interesting identity that you should know about power sets is if order of set A equals to n, then order of the power set will always be 2 to the power n. So here if you see, order of A set was 3. And what was the order of the power set? Power set of A was nothing but 2 to the power 3, that is 8. See, 1, 2, 3, 4, 5, 6, 7, 8. So that is how you can check your answer also. While writing power set, if you have missed out anything, check with this identity if it is 2 to the power n or not. And that is how you can recheck whether you have written down everything correctly or not. So with this, we come to the end of this session. Meet you in the next class very soon. Thanks for watching. Have a good time. Bye bye.